It's a big welcome to all you Beatles fans here watching today. I'm glad you decided to join us in looking at integrals with partial fraction decomposition. All right, so let me give you a little background here. What if you had an integral that looked like this? And so we have the integral of 1 over the x plus 4 quantity squared plus 9. Perhaps you see it, but in Calculus 1, we completed the square. We completed the square to get this right here, and it worked out nicely that we get the integral of the inverse tangent. But what happens when maybe we can't complete the square and we get an integral that looks like this? All right? I mean, we can complete the square, but are we going to get a perfect square back here? Are we going to get a perfect square back here like we did here? Okay, and then how are we going to deal with this right here? The perfect square wouldn't matter as much as what are we going to do with that 3x? Okay, and so what we're going to do is we're going to use partial fraction decomposition. You may remember this from pre-calculus, may not, so let's practice this a little bit and look at the partial fraction decomposition. So here's our example. We'll use this example in red, and we'll take it on the next screen. So what you may remember from pre-calculus is that what we do, we're going to do a little scratch work over here. Let me split this screen here so we can do this. All right, and so what we're going to do is we're going to factor the denominator first of all. So we're going to factor the denominator. All right, and you guys should recognize this. That's x minus 2 and x plus 1. So we're going to factor the denominator in that way. And so then what we're going to do is we're going to write this as we're going to write this equation, x squared minus x minus 2, and it's going to equal a over x minus 2 plus b over x plus 1. So we're just going to, when we factor, and then we just write it as linear factors here, all right? So now what we're going to do is we're going to multiply everything. We're going to multiply everything because we don't like dealing with fractions by x. Wow, this is brutal. Let's try this again. We're going to multiply by the denominator of our original denominator. So x squared minus x minus 2. We're going to multiply that here. X squared minus x minus 2. And we're going to have to do it here. X squared minus x minus 2. But what you know is that hopefully that this divides that out. So what we're left with is 3x. This and this divide out, but what's left over is x plus 1. So we get that equals a times x plus 1. And this divides this out, and we get x minus 2. And so we get plus b times x minus 2. There we go, that's a b, of course it is, all right? And so now what's going to happen is we're going to create a system of equations here, you may remember. All right, so let's scroll down here. I'm going to split my screen a little more, okay? And so what we get is 3x equals ax plus a plus bx minus 2b. And notice that these have x's in them. So we get 3 equals a plus b. And if I scroll down a little further, then we know that a minus 2b, well, there's nothing over here. Well, a minus 2b has got to equal 0. So 0 equals a minus 2b. Okay, and if we solve that, then I think it's fairly obvious to you that when we solve this, we get b equals 1 and a equals 2. And if it's not, then please pause the video, work this out for yourself, but in order to save some time, we're just going to go right to our answers. B equals 1, A equals 2. So when we go back to the top here, all right, b equals 1, a equals 2. So we know b equals 1, a equals 2. So if we come to our integral over here, we can rewrite this as 2 over x minus 2 dx plus the integral of 1 over x plus 1 dx. So we have broken down the integral, the red integral, into two simpler integrals. And so something that we couldn't use a u substitution before, now we've broken it down. And so we're going to be able to solve this. And again, if this doesn't make sense to you, please pause the video and figure it out. But we get 2 times the natural log of x minus 2. And we get the natural log of x plus 1. And there's a plus c there. And so that integral that we once couldn't do before, we now can really easily. And if you want to double check it, do the derivative, work it backwards, and I think you'll see we get the right answer there. All right, let's take a look at another example. It's going to be a little bit more involved, but here it is. You'll notice that the degree here is 2, and the degree here with those two is 3. So the degree of the denominator is still bigger. We'll look in class what happens when the degree of the numerator is greater. But we need to do a partial fraction decomposition because that's the section we're in. Now, if you remember, we're going to take this fraction and we're going to set it equal. I'm just going to say, pretend that we have all this taken out of the integral already. But now what we have to do is we have to do 3 parts. So we have the first part, it's going to be a over 2x minus 1 squared. But since we have that there twice, we have to do b over 2x minus 1. So we have to do both parts. And then we also have to do c x minus 1. Now there are some other little caveats here that we haven't quite covered with partial fraction decomposition, but we'll get to them in class. This will give you the basics. Okay, so if you remember, we're going to have to multiply by the denominator. So we have 2x minus 1 squared times 2x minus 1 times x. Oh, that's not right. I don't need to do all of that there. So we'll try this again. So just x minus 1. And let's do that 3 times. So 2x minus 1 squared, x minus 1, and 2x minus 1 squared, and x minus 1. Okay? And so as we work this out, what we get is we get 19x squared minus 20x plus 5. So that divides that, and so we get a times x minus 1 plus b. One of those will cancel out. So b times 2x minus 1 and x minus 1 plus c. So that and that cuts out times 2x minus 1 squared. Okay. So we use the power of television here to simplify. And so when you simplify, we get this. And now notice we can put these together. We have an x squared here and an x squared here. So let's write this out. We have 2b plus 4c equals 19. I wouldn't color code all these. All right, and so then let's look for the x's. We have this one and this one and this one. So we have a minus 3b minus 4c equals negative 20. And we have minus a plus b plus c. And that equals 5. Okay. I'm not going to go through and solve this with you. We're going to let the power of television do that for us. And so we get A, B, and C equal. So there's our solutions. 1/2, 3/2, and that should say 4. All right. And then let's go back to look at our original equation. It was here. If we rewrite that now as 3 integrals, we get this right here. And of course, your solutions are, I'm not going to take the time to work that out, but please pause the video if you want to know how to do this and watch it. So we get -1/8x minus 4 plus 3/4 and the natural log of 2x minus 1 plus 4 times the natural log of x minus 1 plus a constant. All right, so those are two examples of partial fraction decomposition. We haven't talked about everything you can do with that, but this gets you the basics. Hopefully you guys remember a little bit about that partial fraction decomposition. Excuse me. Hey guys, I thank you for watching. I apologize, it's a little bit windy. I tried to save as much time as I could using the magic of television, but anyway, that is where we are. We'll see you in class.